Okay, we're going to start recording here for section 1.4. So this is, oops. Oh my, thing doesn't appear to be working. Oh, there we go. So we'll say, all right, section 1.4, this is going to be quadratic equations. And what a quadratic equation is an equation of form ax squared plus bx plus c equals 0 with a not equal to 0. So anything that can get down into that form is what we would call a quadratic equation. We're going to talk about something called the zero factor property, and then we're going to solve some stuff by factoring that uses that property. So we get the zero factor property. Which basically says if A and B are complex numbers, with A times B equal to 0, then, so if I have two numbers that multiply together equal 0, either A is 0 or B is 0 or both equals 0. So for the zero factor property, if you have two numbers multiply together it equals 0, has to be the case A is 0, B is 0, or both of them equal to 0. So we're going to look at example 1 here, which is going to have us use the zero factor property to solve by factoring. So they want us to solve 6x squared plus 7x equals 3 by factoring. So step 1 is I need to move the 3 across as a negative 3 to get all my terms on the same side. And then I'm going to write out all the different ways I can make a 6x squared. So I can either do a 2x and a 3x, or I can do a 6x and a 1x. And I'm going to write out all the different ways I can make 3. So I can make a 3 and a 1. And I'm going to start looking through with combinations of these multiplied to these and see if I can generate a 7. So like 2x times 3 is, that's a 6x. 3x times 1 is a 3x. Regardless of what signs I put in there, 6x plus 3x can make 9x's. 6x take away 3x's can make 3x's. I can't get a 7x out of that. So that's not the right combination. So I'm going to move on to the next one, which would be kind of pairing them up like that. So 3x times 3 is a 9x. 2x times 1 is a 2x. Now this one, if I do 9x take away 2x, I could make a 7x. So this is going to be the one I want to go with. If that hadn't worked, then I would look at 6x pairing up with the 3 and 1 pairing up with the 1. Then 6x pairing up with the 1 and the 1x pairing up with the 3. And so okay, I have a 2x and a 3x. 2x is pairing up with 1, so by outer foil, 2x is going to pair up with 1 by the outer foil. 3x pairs up with 3 by the inner foil. For this to work, the thing that becomes 9 needs to be positive, and the thing that becomes 2 needs to be negative. So I have positive, the 3x times the 3 becomes the 9, and negative 1 is the 2x multiplied to negative 1 makes a negative 2. So, okay, we got two different terms that multiply together to equal 0. So from the zero factor property, either the first thing equals 0 or the second thing equals 0. And then we can individually solve those. So negative 3 halves is one solution. On this, we add the 1 across, divide the 3 on over, and we get our second solution. Okay, so that's using the zero factor property and factoring to solve a quadratic equation. So next we got this thing called the square root property, which says if x squared equals k, then x equals positive square root of k, or x equals negative square root of k. And a lot of times, instead of writing this as x equals positive square root of k or x equals negative square root of k, we combine it into a single statement and say x equals plus minus square root of k. So we're going to use that to solve a couple problems here from example 2. So we're going to say, part A, we want to see how does x squared equals negative 25. Let's solve that for x. And part B, what if we had something like x minus 3 squared equals 12. So if we want to solve x squared minus 25, we would say, okay, let's get rid of the square by taking plus minus square root of the opposite side. So there's really two solutions here, positive square root of negative 25 and negative square root of negative 25. Now I can't simplify this down till I make this a positive square root, so I need to pull I out. And now I get I times square root of positive 25. Square root of positive 25 is 5, so I get x is plus or minus 5 times I. On this one, we want to get rid of the square, so we get x minus 3 equals plus or minus square root of 12. This is a positive square root, so we're able to simplify this. Square root of 12 is the same as square root of 4 times square root of 3. I'm going to take the negative 3 and add it across, so I get x is positive 3 plus or minus square root of 4 is 2, square root of 3, and we leave our answer like that. We're not able to add the 3 and the 2 together here because of orders of operation. The 2 has to multiply to the negative 3 before it adds to the positive 3. So you're not able to do the 3 plus 2 and 3 minus 2. You have to keep it like that. Okay, so next we're going to solve a problem or two by completing the square. So we'll take a look at that. So for this example, we want to solve x squared minus 4x minus 14 equals 0 by completing the square. So for completing the square, we need to use the completing the square equation, which we're writing up here. So our goal is to take this left-hand side and match it up term by term with the top part here. The negative 14 we're going to slide across. I'm going to create a place to put the blank because negative 14 wasn't b over 2 squared, so I'm creating a blank to put whatever b over 2 squared happens to be. Once we calculate it, creating a blank to add that in. And whatever I add to the left-hand side, I have to add an equivalent amount to the right-hand side to keep stuff balanced. So I'm going to go through term by term and say, okay, x squared is supposed to pair up with x squared. So they do. So far they match. The next thing, we got negative 4x here. That's supposed to pair up with bx. Well, if b equals negative 4, then negative 4x plus bx would be plus negative 4x. The middle terms match. Now I need to figure out what b over 2 squared is. So if b is negative 4, then b over 2 is negative 2. And b over 2 squared, the value I'm looking for, negative 2 squared is 4. So I'm going to put a 4 in the blanks here. And now when I check this, b over 2 squared here, that's 4. I have a 4 there. So now my x squared term matches up, my bx term matches up, and my b over 2 squared term matches up. So basically now this top part here can factor down as to x plus the b over 2 value, whole thing squared. So my left-hand side of the equation that paired up with the completing the square formula can factor down as x, and then the b over 2 value is what I add in here. B over 2 is this middle number, it's negative 2. So this is x minus 2 equals 14 plus 4 is 18. And then from here, we're just going to use the square root property. We want to get rid of the square. So we get plus or minus square root turning up on this side. Square root of 18 is really square root of 9 times square root of 2. And then this negative 2 is going to slide over, become a positive 2. So we'll say x is 2 plus or minus square root of 9 is 3. Square roots of 2. And we got our problem solved. So we're going to do another example of completing the square. Then we'll do a couple of quadratic formula problems. And then we have a couple miscellaneous things we're going to do, and then call it a day after that. So for this one, we're told to solve 9x squared minus 12x plus 9 equals 0. Again, I'm going to write out our completing the square formula here. So we'll say x squared plus bx plus b over 2 squared factors down x plus b over 2 squared. Now, step 1 in this problem, I have to divide everybody by 9 because my completing the square equation I just put over here only works for an x squared. It doesn't work for a 9x squared. So I divide everybody by 9. I get x squared minus 4/3 x plus 1 is equal to 0. I need to slide the 1 on over and create a spot to put the b over 2 squared value, and then we'll start pairing stuff up. So in this case, x squared pairs up with x squared. B would have to be negative 4/3 because negative 4/3 x is supposed to pair up with bx. So let's see, b over 2 would be negative 2/3, and b over 2 squared would be positive 4/9. I'm calculating the b over 2 as an intermediate step because when it factors up, we're going to need that b over 2 value right there. So okay, x squared pairs up with x squared. If b is negative 4/3, then negative 4/3 x is negative 4/3 x. And b over 2 squared would be positive 4/9, so we add in 4/9. The left-hand side now matches up with the equation, so it can factor up according to the equation. So it'll be x, and then we'll do the b over 2 value is negative 2/3. That's going to equal... I need negative 1 in terms of ninths. That's negative 9/9 plus 4/9 is negative 5/9. So to go through and finish this off, we get rid of the square. We take plus minus square root. I don't want to deal with square roots of negative, so I'm going to make that positive and put an I out front. The negative 2/3 slides across, becomes a positive 2/3. That'll be plus or minus I times square root of 5 will be the new top number. Square root of 9 is 3, and we get our answer like that. So that is a couple of completing the square problems. Again, you try to make one side, in our case the left-hand side, match the top equation. Once you get the left-hand side matching the top equation, you can factor it down, and once it factors down, it's plus minus square roots, and then just get the x by itself. So next bit we're going to look at is quadratic formula. So the quadratic formula says the solutions of ax squared plus bx plus c equals 0 are given by x equals negative b plus minus square root b squared minus 4ac, all that over 2a. So we're going to solve a couple problems by the quadratic formula. So for our first example, we want to go through and solve x squared or minus 4x equals negative 2. In order to use quadratic formula, I need everything on one side compared to 0. So for this, the first step's move the negative 2 over as a positive 2. Then I need to identify what's acting as a, b, and c. A is the number in front of x squared. B is the number in front of x. C is the constant term, which is a term with no x. Do not bring the x values themselves into the quadratic formula. So we get x is negative b plus or minus square root of b squared minus 4 times a times c, all that divided by 2 times a. So let's start to simplify that down so we can see what our answer is. So it's 4 plus or minus square root of, let's see what's under here. Negative 4 squared 16 minus 4 times 1 times 2 is 8. 16 minus 8 is 8. That's all over 2. This does simplify, but I need to get the square root of 8 broken up first. So square root of 8 square root of 4 times square root of 2. So I have 4 plus or minus 2 square root of 2 over 2. So I can do a cancel where the 2 here cancels. The 4 cancels, leaves a 2. The 2 cancels, leaves a 1. And we get x is, that'd be a 1 downstairs. 2 plus or minus square root of 2. So 2 plus or minus square root of 2, it's really over 1, but dividing by 1 doesn't do anything, so we can write our answer in that form. So we got 1 or 2 more of these to do, and then we'll get to the last group of problems. So this time they want us to solve 2x squared equals x minus 4. So again, I've got to scoot all the terms over to the same side so I can get my function where I'm ready to set up to identify a, b, and c for the quadratic formula. So a is going to equal 2, b will equal negative 1, and c will equal 4. So we'll get x equals negative b plus minus square root of b squared minus 4 times a times c, all that over 2 times a. So this will be 1 plus or minus square root of, let's see, that's 1 minus 32. So that'd be negative 31 over 4. So if I just make that a plus or minus I square root of 31 over 4, that will be the simplified form. 31 doesn't have anything nice in it. There's nothing that can cancel with a 4, so this will be our solution. Okay. See, for the next group of examples, we want to solve a equals pi d squared, all that over 4 for d. So we want to get the d by itself. So step 1, we got to multiply the 4 on over. So we'll get 4 times a equals pi d squared. Step 2, this pi is going to divide across. So we get 4a over pi equals d squared. And the final step, to get rid of the square, we're going to take plus minus the square root. And that will be our answer. So another example. Suppose we have RT squared minus ST equals K. Tell us R is not equal to 0. And we want to solve for T. So our goal is to get T by itself. But we kind of bump into a problem where there's multiple t terms. I'm going to subtract the k over. And I'm not really able to get them by themselves. So what I do have here is the setup to use quadratic formula. It's ax squared plus bx plus c. So in this, instead of x's, we use t's. A would act as r, b would act as negative s, and c would act as negative k. So if I was to put that into the quadratic formula, instead of x equals, I get t equals be negative b, which is negative s, plus or minus the square root of b squared, which would be negative s squared, minus 4 times a is r times c is negative k. All that over 2 times a, which is 2 times r. So t will equal, let's see, minus a negative s is a positive s, plus or minus, let's see, that'd be square root of negative s squared is s squared, minus 4 times r times negative k, minus the negatives plus, you'd have 4rk, and then all that over 2r. Okay. So the final bit that we're going to do here is based off something called the discriminant, which is the part under the square root from the quadratic formula. So if we look at this, all right, here, this is the discriminant. So what we're going to do is we're able to classify solutions based on this discriminant. So if we have b squared minus 4ac, there's going to be 4 different cases that this kind of, our answers will break up into depending on what information we have. So b squared minus 4ac, it could be positive, and it could be a perfect square. Could be positive, but not a perfect square. Could be 0. Or it could be negative. So, build our table. First thing here we have is the number of solutions. So we get 2 solutions if it's positive, perfect. 2 solutions if it's positive, not perfect. We get 1 solution if it's 0, and 2 solutions if it's negative. So then the type of solutions we get would be rational if it's perfect square. It's irrational if it's not a perfect square. It's rational if it's 0, and it's non-real complex if it's imaginary. So we'll do an example seeing how to use that table. So we'll say classify the solutions of 4x squared plus 6x minus 3 equals 0. So step 1, figure out what b squared minus 4ac is, the discriminant. B in this case is 6, so we got 6 squared minus 4 times a is 4 times c is negative 3. This will be 36, let's see, negative times negative is positive, 4 times 3 is 12, 12 times 4 is 48. So this will add up to, let's see here, that's 14 plus 70 is 84. This is positive, but 84 is not a perfect square. So positive but not a perfect square. Therefore, you get two solutions, and the type is irrational. So you get two irrational solutions.